Okay, I'll do a quick video because I've got a couple of questions from Steve and some other folks about how the control linkages for the tail work, because they're kind of complicated, as you can see, right? So this is the tail of the triplane. I've got the elevators set up, and you can see everything is pull-pull linkages. So the kit comes with a push-pull solid wire. The real aircraft had all pull-pull cables, so I updated it to be pull-pull cables. The cables for the elevators are interesting because you can see they're split. There's two of them, and these are the upper wires to the top control horns. And the lower wires run down here underneath. But the thing that's interesting about it is you can see the angles that the upper wire actually passes out of the fuselage and through the stabilizer. It goes in, and it comes out the top to connect to the top horn, right? And I'll show you why that is. Now you can also see there's dual cables. So there's two pairs of cables, one for each elevator half, which the elevator halves are connected with a joiner. Now you could do just one side, but I did both sides because the real aircraft had both sides, and I think there's two reasons for that. One, it was definitely redundancy, but I think it's also because probably the joiner tube was not stiff enough, and if you pulled on one side, air resistance might make the other side twist. So they had pairs. I don't think they actually did a pair of wires for the rudder. They might only had a one set of cable, or they maybe had a horn with double cables. So they might have done redundancy that way. I'd have to go check. But anyway, this is how this is set up. The angle is required because for CG purposes, we have to put all the equipment up front. So everything, the electronics, servos, batteries, all of it, you shove it as far to the nose as you can. The reason being is, for the scale look, the nose is really short relative to the tail. And the reason was, 100 years ago, the engines were heavy, they were underpowered, so they kept the nose short so you wouldn't have this big heavy weight hanging out front, but then the tail had to be fairly long to balance that around the wing. Now in a model, our engines are pretty lightweight, so we don't have a lot of engine weight. So in order to avoid adding a few pounds of lead, we move everything up. So right up here in this compartment behind the engine, I have the servos. This one that's the elevator servo. It's got a really short arm that hooks up to a tiller that I made out of an old double control horn and some bearings and such. And then that's connected to cables which run through the fuselage, actually through the scale cockpit. They pass through a former, and there's a piece of balsa, a fake former that has cable guides. They're just pieces of plastic tube glued in there, and then the cables go up to the tail. So looking at it vertically, we got the servos right here, tiller, wires run through the guides, and then they angle up. And that was actually to get it works best that way, and it gets the scale look, the proper angles. Now I'll show you how it operates. Let's power up. Radio on. And we'll power on. Got some hidden switches and just one battery hooked up temporarily for testing. So there we go. So if I move the elevator, you can see the servo moves, which drives the tiller and pulls on those cables. And gets our elevator moving, and I'll give you a look so you can see the motion. All right. So each side of that tiller is dual cables, and you can kind of see, it's a little hard to make out, but I think you can kind of see, you can kind of see right, let's see if it'll focus on it, right there, the two wires. So the wires split, and there's two on the left side, two on the right side, which, one goes to the upper, one goes to the lower. I used a really short arm on the servo because we were trying to maximize resolution. So these radios, for folks who are watching this that aren't RC modelers, the radios are digital. There's something like 2048 available steps of resolution up and down. But and that translates to, if you max everything out, to about plus or minus 60 degrees of angle on the arm of the servo. But I only need about 10, 12 degrees of angle at the elevator. So to get the best possible resolution, I want to use a really short arm on the servo connected to an offset linkage and a big arm on the elevator. And you can see center to center, it's like 2 inches, those control horns. Whereas at the servo, I've got like 3/8 of an inch. So it gives me a lot of mechanical advantage and allows me to use all that geometry. Setting all this up, when I built it, took at least a weekend, if not the better part of a week, to figure out the routing for all the wires, install the guides, get the angles, set everything up, make templates to mark where the cables came out. Then after it's all covered and painted, I had to use those templates to cut the holes in the fabric. I put these little leather reinforcement patches, get everything rigged up. Took a while to rig it up, and last couple days I've probably spent 2 to 4 hours adjusting it, getting all this centered, getting the tension set, and playing with the size of the arm and the endpoints to get everything maxed out with resolution. So if you look at the radio, I can show you the endpoints, elevator. That's pretty good. The max it can go is from 150 to 150. Generally, if you're on 100 or better, you got pretty good resolution. So I got like 110 on one side and 100 on the other side. A little bit of offset because the arm is not completely 90 degrees. That's not unusual. But that's pretty good resolution. And that's how it works.